Good afternoon, everybody. I'm Ted Fyock, the WHIN Purdue Managing Director, and I'd like to welcome you to our monthly Lunch and Learn webinar series. This webinar series is brought to you by the Purdue WHIN manufacturing team, and also sponsored by the Purdue Manufacturing Gateway, the WHIN, which is the Wabash Heartland Innovation Network, and all of our research team and folks working at Purdue on the WHIN project, including groups like INMAC, DSEMI, and others. So welcome today. Today's topic is lasting longer, fewer breakdowns, unlocking predictive maintenance with IoT. Let's go to the agenda for today. Do a brief presentation. We'll talk about the upcoming webinars that we have. I'll present Jacob, who's our presenter today. When Jacob finishes with his presentation, we'll go to a Q&A session. If you'd use the chat feature to put all of your questions into the chat feature, we'll go through our Q&A session, and then we'll have some closing comments and a brief video on the Purdue Manufacturing Gateway. Let's go to the next slide. Just want to remind folks, we have two more webinars coming up. On May 18th, we'll have a supply chain localization session talking about the supply chain portal and import analytics tools that are built into the supply chain. DSEMI will be presenting most of that work during that seminar. And then on June 29th, we have a seminar dealing with digital work instructions, and part of the IMI INMAC team will be presenting during that session. Let's move on. With no further ado, I want to present today's presenter. Jacob Coffing's a senior engineer out at INMAC. For those of you who do not know, INMAC is located out north of out at Research Park, out in the Indiana Manufacturing Institute facility. This is also the site of our intelligent manufacturing test bed that we've developed over the last couple of years, along with part sponsorship funding from the WHIN project and others. All of Jacob's contact information is there today. And I'm going to turn things over to Jacob, but before I do, I'm going to put my contact information into the chat window. At the close of the session today, if any of you have any questions about what we're doing as part of the WHIN Purdue manufacturing team, whether it's projects, education needs, anything like that as part of the WHIN project, just reach out to me at any time. So I'm going to turn things over to Jacob and have him present on the main feature today. Thank you.
Thank you, Deb. All right, so today's seminar is going to be about IoT, machine sensing and machine health, and predictive maintenance and costing. Some of the deployment opportunities are on motors. That could be a motor running, a pump. It could be a motor within a machine tool, multiple types of motors, electrical motors and whatnot, pump systems, robotics, compressors, conveyor systems, CNC machines, injection molding machines, or almost any mechanical application. The next slide will mostly be discussing CNC machine tool deployment. However, the same sensors and configuration can be used on a wide range of industrial equipment. Next slide. Next slide. Go ahead. Yep. So there are a few different types of maintenance. So a lot of companies, unfortunately, work in the incident range where they are running, a specific product or machine until they meet that quality threshold. It might be that their product all of a sudden goes out of spec. It might mean their machine's down. But usually, they run until some threshold is met, then they have downtime. Usually they're not prepared for this downtime, so they have to order parts. They might have to get a tech in. So it could be a rather long time where they're losing production, but also, having to pay out of pocket to have a piece of equipment fixed. So then they might run a little longer, go out of spec, have a quick fix, run a little longer, go out of spec, and they're down for a long time again. So what a lot of companies try to implement is the scheduled maintenance, where they, once a month have PMs on a specific piece of equipment where, they never let it get to that high, threshold. But this also can create quite a bit of downtime. Then in companies I've worked for, a lot of times, they're pushed to get product out the door, so they can't afford to shut it down, do the PMs. So a lot of times, maintenance personnel might have to just, bypass the PM or check off that they've done it. So in result, they end up running an incident type maintenance schedule anyway. So the last slide, go ahead. So what we're working on is predictive maintenance or quality control, where we put sensors and take all the process parameters of a specific part into a machine. Then we can start to take, algorithms and know, once A and B happens, the machine's getting ready to go out of spec. So then say it's a coolant pump, for instance, you can know, on historical data that when X amount of vibration comes out of this motor, the pump or something like that, it's getting ready to go bad. That way you can have parts on order, then, schedule it and maybe move product to another equipment. We're not, completely losing production. And, you can be down for as little time as possible, all the while you're not, doing any unnecessary maintenance. Next slide. So how we typically set up a machine health tool. We use readily available industry sensors. So we're not, making new sensors, anything like that. We're using sensors that are already out there in industry. You might already have some on your equipment. Then we attach these sensors to new and used equipment. So you don't necessarily need, brand new equipment for IoT to work for you. We can put it on, 1920 transfer lines. We can put it on presses. You can put these sensors on almost any, type of equipment. One more slide. Then this is where we really come into play with the data analytics. So we take that sensor data, the controller data, that, if the machine has a controller, we'll establish a connection via MT Connect, product inspection reports, operator log sheets when they change the tool, when, parts go out of quality. That way we can overlap what's happening at the machine with the sensor data to start to get those data sets for predictive modeling. Also the process parameters. Next slide. So what is being monitored via these sensors? So we can monitor power consumption, vibration, sound, temperature, and we can do it on the motors, the air compressors, pumps. You can do anything in the machine. Sometimes the machine will give you the cutting force, the spindle RPM, that sort of thing. We even measure down to the coolant concentricity or the quality. So for instance, like the coolant concentricity in machine shops is something that unfortunately a lot of time is neglected. It's a necessary evil. And, I've worked for companies where, the coolant starts to go bad, they pour bleach in it. And, that plays even more havoc on seals and bearings and things like that in your machine, let alone, your part quality. So, a lot of this can seem overwhelming. There's sensors everywhere, but, when we first started this, we put probably 40 sensors on, one piece of equipment. And over time, we've learned what's necessary. If we monitor before or after, what actual data do we need and what is useful. Next slide. So why monitor your equipment? A popular feature pertaining to machine monitoring systems are production dashboards. They allow your company to display the machine status and production data for every machine in the plant. So, if your plant manager or scheduler, they may not know the process necessarily, but from, their office, they can pull up these dashboards and know what job you're working on, how many parts have been completed, that sort of thing. Engineers and managers alike want to be able to see exactly what's happening on every machine at a given moment. What part is running, how many parts have been produced on that job, tooling information, also how much the machine is up versus downtime. Is that it's not necessarily just for maintenance either. Maybe that operator has to go to the other end of the plant for a quality check or for a specific piece of tool, but they can look at this dashboard and see trends, see that, hey, this machine sets every other hour for 15 minutes. And they might be able to track down, hey, that employee has to actually go to the other end of the plant, for a quality check. So it can help in a lot of different ways. Next one is machine monitoring. Allows you to evaluate your machine and factory production both on a micro and macro scale, where you decide what data is important to you today. Some companies, they look at it and think there's a lot of data analytics. We're not really into that. But on a smaller scale, just the dashboard can be, very helpful for companies to know exactly where they're losing time, money on, specific equipment, or they might be able to just, take a look at it and say, hey, these numbers don't quite look right. That graph is spiking, the spindle vibration, or, the pump's starting to get an extra vibration, and then they can start to look into it further. Other engineers and managers want data logs, though. They want with data logs, machine analytics can come into play for detection in part quality or machine process errors or anomalies. How this is done can be reviewed on the next slide. Next slide. So with machine learning error detection, you have various machines. It can be injection machine, pump, pipe bending. I really want to emphasize, yes, I talk a lot about subtractive manufacturing because that's what my background's in, but this can be taken almost to any, mechanical application. Then we attach the IoT sensors. Then we can start to, do feature extraction. So if we have those operator logs, we know, a tool broke or a pump went bad. Well, we can look at that data that, just before the incident occurred, and we can start to extract that, that data set. And then we can look, put it into stored machine parameters. So we know if A and B are met, C is to follow. So it can be used for, if we know all of a sudden the vibration in the spindle motor and the power draw spikes, we know maybe the spindle bearings are getting ready to go out. But on another note, the stored machine parameters can be for benefit. If process A and B is met, this data is met, that you should have a quality part unless something outside of the normal realm happens. Then, you get to the classification area where, you start to know this, if A and B happens, we know C and that sort of thing. And you can start to predict what's going to happen with your machine next. Next slide. So some common barriers for IoT adoption with small and medium manufacturers are new and old equipment. So some companies, they have new equipment and old equipment. It's not an issue. We can help with some type of solution with either or. Some companies where, I don't make the same part over and over. I'm a job shop. I might be cutting aluminum today, titanium the next day. I might be making 40 different parts or products in a week. It's not an issue. There are solutions for that. Then there are others, they're a production shop. They run the same thing over and over. That's not an issue either. It actually makes a little easier, but it's not a problem. You don't have people on site that can do the data analytics. It's not an issue. That's what we're here to help you with. Are you worried about cost? We're willing to work with you as your free trial prior to you investing in sensors and personnel. Next slide. So companies that, have a single part production, they're mass producing something, making the same thing over and over. So how we would typically set that up is mount sensors. The sensors would be mounted on key parts of the equipment: motors, bearings, ball screws, pumps, etc. Then if there's a control available, we'll establish a connection with MT Connect to pull data off that equipment, whether it's, a part counter, what tool has happened, what program is up. We can pull some of that data to relate back to the sensor data. Data collection. We'll start a baseline data collection trial of a healthy machine and a healthy cycle to establish the parameters. So we know your machine today is running healthy, has a good product. Well, then we can start to, run products, and over time we get this baseline, so to speak. We know, within this parameters, this is a healthy machine. Then we need the operator log. So operators should document all tool changes, scrap product, broken tools, or any issues that may arise during daily production. So if we have this operator log and we know what the healthy machine is, and we also now know when a part goes out of spec, we can use that operator log and look at the timestamp and go back and find that data set that then will allow you to know, hey, this is my threshold. This is when the part quality goes out of spec. Then also the inspection reports, operator random inspection, and any final inspection documents should be kept. That way we can overlay that with the data also. I mean, over time, we could possibly even get to the point where, if we have this, these data sets that we know whether that product should be a quality part before it ever leaves the piece of equipment, before it ever makes it to a quality check. Then there's other companies, job shop, custom manufacturing, where they're making 40 different things a week. It's never the same thing over and over. So you can't get that baseline of a normal cycle because you're making multiple different types of parts, materials, tools, that sort of thing. But a lot of it's the same. We still mount the sensors on key parts of the equipment, the motors, bearings, ball screws, pumps, things of that nature. The control is the same. If there's a control available, we establish a connection with the MT Connect. Then data collection, it's a little different. So, in a machine type environment, we tailor a part specifically to your equipment, maybe even your tooling. So we'll help you design a part that's maybe 2 or 3 tools. It's a 15-minute setup, a 5-minute cycle that we can run. So we know today your machine's healthy. We run this, then over months, weeks, days, you can set up and run this. It takes 20 minutes to set up and maybe run this part. Then you can start to overlap that data. So if somebody has wrecked a machine or something like that, you can go back and run this part and see where it's affected. So, a lot of companies will use like a Renishaw ball bar in a CNC machine to check quality. Well, this is kind of an early detection also, where you can overlap that data over time and start to know, hey, maybe there's a little extra vibration in this motor, or this motor is making, a funny ticking sound. Then you can, overlap that data and see the trends and try to be prepared for the downtime. Inspection reports for the sample parts should be kept with the machine maintenance documents also. That way, not only, does this part meet, this realm of sensor data, but what was the quality of the part also? Because that's obviously a very important thing. Next slide. Go ahead and tap it through. There we go. So once we set up sensors and establish, a connection with MT Connect, we'll build custom dashboards for your specific application. This one happens to be for a HOSVF too. Then we can put all the data on it, the part count, the spindle speed, load, the position of the machine, how many parts were made in the last 24 hours, 7 days, the power consumption, the spikes in current, spikes in vibration, temperature. We can really customize it to where you can look at this and know what your machine's doing and look at the historical data as well. Next slide. So we did a sample vibration test. So the cut parameters where we were using a 1/2-inch end mill with an 1 1/8 protruded out of the holder. It was a 0.8 depth of cut, a 75 thou step over at 12,000 RPM and 500 inches a minute. So this is just, new tool versus slightly, edge broke tool there. And you can see the vibration with the new tool is in the range of 1 to -1 meters a second squared. But with the worn tool, it almost doubles up to the 2 to -1.5 meters a second squared. So a story I like to tell here is, I worked in a company and we had some new employees and they'd been training with an operator for a while, and we thought he was ready to take over a specific piece of equipment. Well, some time went by and I could hear a loud sound coming down from his machine. So I went down there and he had a part there and it was like a fuzzy surface finish. The part was black. And I asked him, I said, have you changed any inserts recently? He says, no, it's still cutting good. And I said, well, have you done any quality checks? And he said, no, the guy that trained me told me this is a pretty open tolerance part. I don't need to check it. Well, obviously it was somewhat faulty training, but on the other hand, it was still his responsibility. So I stopped the machine, opened it up, and he didn't even have an insert in the holder anymore. He was cutting with the seat of the tool holder. So, it was a pretty, close to being a catastrophic failure. But a tool like this, where we can see that vibration and correlate it with the sound and the issues, detect, hey, this tool broke or this tool's wearing. And it can also be used as an operator training device, where if they have that dashboard there and an alarm pops up, excess vibration and cutting tool, then they can start to correlate with what they heard in the background, the noise the machine was making, that sort of thing, to what's happening. It can be used as a training tool for your operators as well. Next slide. So here are the results of the sample vibration test. So this is the new tool, somewhat nice finish. If you click again, And this is the use tool. So you can see that instead of, some people that might not know think they kind of look the same, but they're on the right-hand side. The tool's more or less shearing the material. It's not really cutting anymore. It's the tool's jumping, skipping, so to speak. If you click twice more. So the surface finish on the left was an RA of 0.447, then on the right of 3.188. And this tool was not, crazy worn. This is something that maybe not a novice, but a medium type operator would still be trying to operate. They might not know, how bad of an issue it is, but over time, it's going to eventually, if you let it go, create a bad part. The surface finish or tolerancing is going to go out. Next slide. So this is sample vibration test 2. It was a 2-inch face mill with 6 inches protruded, 0.2-inch depth of cut, 1.2-inch step over at 12,000 RPM and 150 inches a minute. Once again, you can see the new tool versus the used tool, the meters per second squared almost doubles. With the new tool, it's in that 7.5 to negative 7.5 range. On the other one, it's 13 to negative 10 range. So it's, this tool also was not worn hardly at all. It was even less so than the one before. There were no chips in the insert. So, even a seasoned operator might reach in there, feel the insert, feel the cutting tool, know there's no chip in the insert. They might think it's fine, but it's actually creating almost, twice the vibration on the spindle, which in return is going to cause, premature wear also. Next slide. So you might be thinking, that's a lot of sensors on a lot of different areas on, on equipment that, it doesn't really pertain to me. It's too much. We can't do it all at once. So it's not a system where you have to put 100 sensors on your machine. If you have a specific issue, you're having trouble with one specific, piece of equipment, we can try to figure out a custom solution for it. So for one instance, we worked with C&D Technologies. They had a lead molding machine. The issue was lead would splash out of the mold onto the hydraulic hoses and lead to hose failure. So their first solution was to add a splash guard around the mold. However, lead still would find its way around. It's a pretty nasty environment and still get to the hose, leading to downtime. So a typical shutdown, maybe 2 to 3 hours to clean up the fluid, an hour to repair hoses, plus the cost of hydraulic fluid and the loss of production. So our solution was to attach a tank level monitoring sensor tied to the PLC, which would give an alarm and shut down if the tank level drops, at a fast rate below nominal operating range. So this would allow for minimal loss of the fluid and less downtime. Yes, you're still gonna have to fix the hose, things like that, but it's not as big of a mess because it's kind of, this isn't an area where there's, slow wear over time. It all goes from, optimal range to a hole in a hose and fluid going everywhere. So the quicker you can shut it down, minimizes, the time that you're non-operational. Next slide. So currently we're running a NMAC Burke IoT sensor project. So if you're interested in anything that we spoke about or would like us to take a look at a specific scenario in your company, we are currently seeking out industry partners for testing sites based specifically around CNC machine tools and other mechanical applications. What's needed? We just need access to that equipment, network, your operator logs, and quality checks. Cost. Currently we're providing these services for one piece of equipment at no cost. At the end of the test, 3 to 6 months, if your facility would like to keep the sensors, they can purchase them from NMAC at cost. At this point, NMAC and Burke would like to help your company implement the solution throughout the entire company if you see the added benefit. If you're interested in joining, please contact me at the contact information below. That's it.
Thanks, Jacob. Any questions or comments at this point in time? I don't see anything in the chat presently, so if you have any questions, I guess we've got a fairly small group. If you want to unmute and ask your question, that'd be fine, or just type it into the chat. Jacob, if someone has a project they'd like to interface with Purdue or the NMAC team, how do they go about starting that process? What's the best?
Either they could contact me or you or the Purdue Manufacturing Gateway. That's what it's here for. NMAC might not be the best solution for your given issue, but there's a multitude of resources here at Purdue, and that's kind of what the Manufacturing Gateway was created for, to help you get in contact with the correct personnel.
Jacob touched on one point about the gateway, and at the conclusion here, we'll have about a 2.5-minute video about the gateway. But a lot of our work with the Purdue project, with the WHIN project, is really to help manufacturers get to the next level on technology. Sometimes that might be, as Jacob described there, a single sensor in an application, or it could be a multiplicity of sensors. We are engaging with a number of companies on a number of different projects, some complex technology implementation projects. Sometimes we're assisting companies with non-technical problems that they have. So, feel free to reach out to us, and, we'll see what your problem is and see how we can help. Any other questions? I have one question here from Bob. We do not have a CNC, but working extensively on industrial Internet of Things. When do you expect to take on other production processes? We heat treat and do discrete metal forming on sides and presses.
No, go ahead.
Go ahead, Jacob.
Yep. So, we're already currently working on, injection molding machines, things like that. Currently, we do not have anything on the metal forming on presses or things like that, but it's definitely something that, we're interested in. If you feel a need, feel free to, reach out, and we'll see what we can come up with. But I mean, this, like I like to, express, it's not just a CNC tool. A CNC tool just happens to have all the buttons and motors and things of that nature. But I think that it could be very useful on your equipment also, and we'd love to test it with you.
And I'll reiterate again, every manufacturer is pretty much totally independent of everybody else. Everybody else has their own unique operations. They have their own unique problems, their own unique set of equipment that they have to maintain and monitor. So it's not a one solution fits all. It's almost like a custom application every time we walk into a manufacturing operation. So reach out to us, and we'll be more than happy to look at your particular situation and see how we can help you get to the next level or solve your problem. So do we have any wireless capable sensors for machines that don't easily have wireless access?
Yeah, so we have wired sensors that have, the only difference between wired and wireless sensors, a lot of times wired sensors have a higher sampling rate. So for instance, some of our vibration sensors will get 3 samples in less than a second. With the wireless sensors that are Bluetooth, usually, you can set parameters, alarms, where it'll, sample every 30 seconds then, but usually it's like every 5 to 10 minutes it does a sample. So on a CNC machine, that's not, it's not useful, because a lot can happen in, a second or two on a CNC machine. But on a press or a pump or a motor that's continuously doing the same process over and over, those wireless sensors for those hard to get areas are very useful. You just don't get as much, data at one time.
Any other questions? Well, seeing none, I'll just reiterate again. This is the second of our 4 scheduled lunch and learns. We've got 2 more coming up in May and June. We also plan on probably a full set of fall and winter lunch and learns for the balance of 2021. And we hope probably in the next couple months, we'll get a full schedule together and get out to everyone. But if there's no other questions or comments right now, I want to thank Jacob and the IMI NMAC team for putting together this presentation today. And then if nothing else, we'll go into a short video on the Purdue Manufacturing Gateway and bring this to a close today. I appreciate everyone's attendance and for taking a little time out of your schedule today. If you got any comments at all, just reach out to Jacob or myself or any of the Purdue WHIN team. And everybody have a great afternoon, and let's learn a little bit more about the Purdue Manufacturing Gateway. So let's run that video and then we'll close out. Hello, and welcome to this overview of the Purdue Manufacturing Gateway. Manufacturers face a wide and complex variety of challenges and opportunities on a daily basis, and Purdue University has a wide variety of personnel and physical resources ready to assist manufacturers. However, many manufacturers don't know where to begin in making a connection to Purdue. The solution? The Purdue Manufacturing Gateway. The Gateway's objective is to be your front door to the university. We have made it easy to connect your company to Purdue. How does it work? 3 simple steps. Visit the Gateway website. We're located at purdue.edu/industry/PMG. On the home page, you'll want to click the Manufacturing Assistance tab. This will then take you to another page featuring the Manufacturing Assistance form. Here, you will fill out the form, submit your request for assistance, and hit the Submit button at the bottom of the page. You'll get an acknowledgement that your request has been sent to the Gateway team, and now that's how simple it is to connect to Purdue. Let's look at those web pages. This is the home page. The red arrow is pointed to the Manufacturing Assistance tab. Clicking on this takes you to the Manufacturing Assistance form. Simply fill out the simple form. Near the bottom of the form, you'll have an area to fill out the assistance you are requesting. Could be an answer to a question or a specific problem that you might have. Fill out the information here, simply hit the Submit button, and you'll get an acknowledgement that the Gateway team has received your request. What happens next, the Gateway team will review your request and will have an initial response back to you within 2 working days. It's that simple now to get connected to Purdue by using the Purdue Manufacturing Gateway. Thank you for your time today.